Hello everyone, welcome to a brand new video. Today in this video we would be discussing a DevOps project. This is the third DevOps project that we are looking into. We would be using Terraform along with AWS in this project. So we would be creating AWS EC2 instances and would be looking at how we can attach multiple volumes or EBS block devices to the EC2 instances. In this video, we would be specifically looking at the Windows server or the Windows EC2 instance, and in the coming video, we would be looking at the Linux EC2 instance. We would also be looking into the operating system and we would be creating new drives. We would also try to see how we can extend the existing drive and how to identify multiple volumes if they are on the same sizes. So let's get into the setup. So I would be using AP South 1, that is the Mumbai region, for this demo, and I already have a VPC with me. So this is the default VPC at which I would be creating my stuff. So the first thing that we would be doing is providing the .getignore file. So I am basically putting in a star.tf state and star.terraform. I would be hiding this. What you could also do is a dot terraform star. That means any folder which is outside of the terraform would be ignored. We could actually ignore this, and this is what is needed. So the first thing that we do is we go with the provider block. So the provider block can be extracted from the extreme right of the screen. So I'll actually put that into the provider.tf block, and this is the provider block. The first thing that I insert inside the provider details is the region in which I want to operate, and that would be AP South 1. The next thing that we would be actually creating is the Windows host.tf. So this is the code for creating the Windows machine. The first thing that we should be getting in is the AMI. So I would be using the data block for the AMI to get the details. And so if we look at this, so I have defined the AMI block as cpb00 windows underscore AMI. I'm looking for the most recent one, and this is the AMI that I'm filtering. So this is the latest AMI as of this recording, and the changes that I've made is for the canonical name. You could also get the exact piece of code if you go for instances under the resource block. So you would be getting the first detail over here. This is the data block, and then you would be creating the instance. But before we create the EC2 instance, what I would be doing is looking ahead and creating a security group as well, because we would definitely like to connect to the EC2 instance while we are trying to create the volumes and the drives inside the operating system. So I'll go into AWS underscore security group, and I could copy the exact thing from here. Now this is a demo code, so I'll just copy that and I would place it into my code. So this is for the security group. So this is for the security group. Now if you see, I have hard coded the VPC ID. So the VPC ID is the same VPC that we just saw in the AWS console. So this is the default VPC. I've changed this for RDP, so the port number becomes 3389 and 3389 would be the two port as well. I would be allowing this for the entire internet to come in through, and I'll just leave everything else as default because we would be not using much of the other stuff. The next thing that I would be looking into is the EC2 instance itself. So as you see, we have a very small block for EC2, the resource. So once this is added, what we would be trying to do is getting in the details. So the AMI details would be this. So I'll change Ubuntu with the AMI data block that we had. Now because this is a Windows machine, T2 micro would not work. I'll go with a T3.medium for us to be functional. The next thing that I would need is a key pair. So I would go with CPB00. That's the key pair that I already have, and I would be going with that. The next thing that we could go is security groups, and because this is groups, that means it is actually looking for an array, and I would be getting in the security group details from the above. So as I type in the stuff, I should be getting the details, and I could provide the name of the security group that I want to connect it with. Once the security group details has been filled in, the other thing that I would also be providing is the availability zone. If you see, I am hard coding everything as of now. Now this is primarily because to avoid the length of the video, but you could always make it variabilized and use it as per your recording. The next thing that we would be doing is instead of having the normal root volume, so what we would be defining is we would be defining a custom root volume to be coming up. And if you remember or if you have seen EC2 instances for Windows, they generally come with a 40 GB volume. What we can do is set up specific stuff which would give you details of, which would allow you to change the size and details of the root volume. So if you see, you will go to the block devices section. This is the block device and this is the root volume that can be defined. So I'll go with the root volume, which is over here, and open the root volume block, and the first thing that I would provide is the volume size. Now I'll go with 50 GB volume, so that is 50, and I'll just leave it as it is. I would leave everything else as default. You could also go with the volume type, that is either a GP3 or a GP2 or stuff like that. So you could always give the volume type to be GP3. Right, and that should be it. Then by default, so the root volume is always delete on termination, so optional whether the volume should be destroyed on the instance termination. The default is yes, so I'll just leave everything else as default. I am not going to encrypt this volume, so I'm just leaving it as it is. Now the next thing that we could define is EBS block devices. And for EBS block devices, what we could do is go with this setup. So here also I will be doing the deletion on termination. I will make it as true because that's not default. By default it's not true. I'll give the volume size to be, let's say, 20 gigs, and the volume type should be, let's say, GP3. So I'll just give GP3. I believe I should be putting it inside the inverted commas. So that is volume underscore size and the volume underscore type being done. The next thing which is needed is the device type, and you could define the device that you want to give over here. So we could give XVDF as a device type that we would be looking. If you're looking for some documentation on the naming conventions of the devices, so here I would be attaching these links in the description. So this would give you a fair understanding of what the device types can be and should be when you are working with Linux and Windows systems. So as you see, I have two pages where where they have provided us the details of the device names that can be provided and the available device names. I would be going with AWS Para Virtualization PV because this is supported for Windows, which is listed over here. So Windows 2022, which is the operating system which we are going to launch our EC2 in, is actually supporting this. And the recommended EBS volume names starts from XVDF to XVDZ. So this is the naming convention that I'll be going with and would be creating this over there. And at the very end, what I'd be doing is changing the flag name. So this is demo server, and we'll just keep it as it is. So I would be initializing my Terraform over here. So I will do a Terraform init, and this should actually download the needed binaries into the system. Now, if you see, we have actually used the EBS block devices to actually create our additional volumes. But then there is a very peculiar behavior that happens with EBS block volumes, which I would actually show you once the volumes have been created. So I'll do a apply and would go with an auto approve, so that our EC2 instance gets created. So that is volume underscore type, and so here if you see for root volumes, right, the GB3 type is not possible, so we can't actually give that. So the possible values is GB2 or IO1, IO2, GB2, SC1 and ST1. So I'll go with GB2 for our volumes. Also for the block devices, I believe we can only go with a GP2. So I'll go with this, and I will do an auto approve, and this should actually create our EC2 instance for us. So as you see, our volume should be created. So this is the Mumbai region, and I believe the availability zone in which I was creating the EC2 instance was not supporting the machine or the volume type. So I'll go into storage and I'll quickly show you. So we have these two volumes that are created. Both the volumes are GP2 and type. So this is what we have. So the next thing that we could do is log into the EC2 instance. So I have the public IP with me. So what I would do is mstsc and provide the IP address, and then click on this more choices. I'll use this ADMINIS traitor, and then the password. So as you know, we could retrieve the password from the security console over here. I'll just do get Windows password, click on upload the private key, and I'll upload my 10 key over here. Decrypt the password, and I should be getting in the password. I'll say yes, and this should allow me into the EC2 instance or the Windows server. Now that I have logged into the EC2 instance, because this is the first time that we are logging into this, so this would actually take a fraction longer for setting up the entire profile. Once we have the run command available, we'll be going into disk ngmt.msc, and you should be able to see that there are two disks attached to it, and it is asking us to initialize the second disk. The first disk is automatically initialized and provided with the root volume, that is the C drive for Windows. And if you see, we have now created a new disk, which is the D drive for our new volume. I could open Windows Explorer, and we should be able to see our disk or volume created over there. So the server looks a bit scratchy, slow, but you basically have the details. Now, if you want to increase the size of this volume, right, you could do it from two places. Now, one is not recommended, but the only reason I want to show it to you from here is because there is a small feature of Terraform which would not be able to recognize the changes to the additional volumes that we create. So I can click on modify, and so this volume should now be of 25 GB. And even on the server, if you do a refresh, which is this, you should be able to find the volume. And you can extend the volume from here, and that should be totally fine. And if you refresh the page from here, so the volume should now be 24 gigs in size. But the problem comes is if you try to do a Terraform apply from here with not an auto approve, but if you try to do a Terraform apply, this would actually say that there are no changes to be made on the system. Right. Now, why is this happening? This is actually happening because the root volume or the EBS volumes that are there, right? So Terraform is not actually going to be able to detect the changes to the EBS volumes. So here, if you see, they are giving us a detailed explanation that the block device configuration only apply to the resource creation, and it is not going to take effect any further changes that we do to the block devices. So this is so here you have a note. So currently changes to the EBS block device configuration of existing resource cannot be automatically detected by Terraform. To manage changes and attachments of EBS blocks to an instance, use AWS EBS volume and AWS volume underscore attachment resources instead. If you use EBS block device, which we have done on the AWS instance, which is what we use, Terraform will assume the management over the full set of non-root EBS block devices for the instance, treating additional block devices as drift. For this reason, EBS block devices cannot be mixed with external EBS volumes and vice versa. So basically what it says is Terraform will not be able to detect any changes if made on the console. Also the contrary, if you try to increase the size of the volume on the Terraform code, and if you try to run a Terraform apply, that would also not be helping us. So you would actually see that there are no changes to be performed, and the only thing that you could do is always make sure that you keep editing or affecting or updating the storage on the AWS console. So this is one reason why I would not prefer EBS block volumes for creation of my EC2 resources. So what I would be doing is, instead of creating the EBS block volume, what I would be doing is commenting out the code and would be creating the AWS devices with AWS volumes attached to it. So what I would be doing is, let's copy the existing code from the above. I've already removed the EBS block, so let's remove the EBS block storage. So here if you see, I've given the root volume size to be 50 GB, and I will be leaving it as it is. The next thing that I would be using is EBS volume, so which is this. So it is a resource block with Amazon AWS EBS volume. I'll just give it as example. I'm also making sure that the EBS volume is in availability zone 1A, and the size of the EBS volume currently that I'm giving is 20 GB in size. At the very end, I would be using the resource block of an attachment, and I would be attaching the resource block to this. Now, if you remember, the AWS instance is web, the volume is example, and these two are exactly matching, and I would actually save this over here. If you want to attach another volume, so what you could always do is have another block which says example 2, and that can also be the same size. And what I would then be doing is also providing what I would also do is provide the volume attachment. So I've just made some changes to the copy paste, and that should be it. So what am doing is I'm providing example 2 over here, and the instance is the same. Now if I run this code, so what would happen is okay, so it basically says line number 114 as a problem. That is EBS attachment because it has been updated twice or used twice. So what I'll be doing is updating that, and if I run Terraform apply, so this actually is going to create 6 resources for us. Those 6 resources are: number 1 is the security group, number 2 is an EC2 instance with 2 additional volumes attached to those EC2 instances. So if you actually look for the EC2 instances over here, the existing EC2 instance would be gone, and we should now be getting our new storages. So currently, if you see the EC2 instance with 1 GB, 50 GB of root volume has been created, the EBS volume is still being created. As soon as the EBS volume is created, we should then be able to attach the volumes to the server. So the volumes are also being attached, and if you do a refresh of the console, you should be able to see the volumes attached. Now these volumes, if you see, are also GP2, right? And I have currently these many servers attached to it. So I'll quickly log into the EC2 instance and quickly show you that the volumes have come up. So I'll cancel this. I'll update the IP address, and I would say ADMINISTRATOR, and I would be getting the password from here. From the security page, I'll get the Windows password. I can upload the key over here and click on decrypt password. So this should actually give me the password with which I can log into my system. Now that we have provided the password, the next thing that we would be doing is going into the disk management part and checking if both the volumes have come up or not. Now you would see that the disk would have been attached to the server, but then the volumes would still not be there. So I'll go for MSC, and if it permits me, I would also open Windows Explorer, and you should be able to see that Windows Explorer should only be having one C drive in this PC. What I'll do is initialize both the disks at the same time, and you could open it on a full screen and then do simple volumes, and this would be the D drive, and this would then become the E drive for our system, which is what it looks like. So if you now see, we have two drives, that is the D drive and the E drive, and we have to increase the space of only the D drive, that is this volume. But if you look at the AWS console, you would actually see that the EC2 instance is having two drives. One is XVDG and XVDF. Both of these are 20 GB, and in order to determine which drive is belonging to which server is a very big challenge. So in order to overcome this, what you have to do is you need to go to properties of one of the disks, and if you see that the disk is NVMe Amazon EBS block SCSI, then you need to follow a different pattern wherein you would be actually running a PowerShell script in order to get the details. Let's also quickly look at the disk that is attached, the other disk. So if you see, the location number is 30, the location number of that disk was 31, and the LUN ID, the target ID, and the bus number is all zeros. If it was a normal EBS based volume, right, or what you had to do was just check the block devices and you would have got the details of the system. So if it is just a normal ID, then the target ID would be different. If it is instance store volumes, then the target ID is different. And if it is EBS based volumes, then the target ID would be this. So the target IDs would be 0, starting with 0 and all the way up to 25. Now the problem over here is we are not using EBS based volumes, but our volumes is actually NVMe based EBS volume. So in order to determine that, what we have to do is run a PowerShell script into our system. So for that, I would open PowerShell. I would open PowerShell ISC, and that should be in the administrative mode. Once it is open, it would take approximately 30 to 40 seconds to load and get or download all the plugins that are needed for it to run. And we will run the script once it is ready. So I'll just paste the code and wait for the PowerShell to load in the background. As I said, this is going to take at least 30 to 40 seconds depending upon the system speed and the network speed. Once you run the script, at the end you are going to get a detailed list of all the drives, that is the D drive, C drive and the D drive, and the volume ID attached with that drive. The script is actually provided by AWS itself, so you would not have to change multiple things into the script. You could just copy paste it and run it on all devices. So the script is only going to work if you are using NVMe based storage, right? So if it is NVMe based storage, it's only then that the script would be helping you out. If you are just using normal EBS based volumes, you would have to map the target ID with the target ID on the documentation, and then you could determine which drive letter is being used, and with the drive letter you could map the volume ID. So now that the plugins have been loaded, so let's actually run the script. The script itself takes about 30 to 40 more seconds to run. So we'll just wait for the output. So though we have got some errors, we still have the volume ID mapped to the drive letter. So this should be a very good point of reference. So this volume ID, which ends with 7D073, is mapped to the D drive. Let's actually go to the volumes, that is 70073. I would extend this volume, so I'll just click on modify, and probably I'll extend it only by 5 GB and click on modify. As soon as I do this modification, the volume should now go into in use, but in the modifying state. Even though it is in the modifying state, if I go to the disk management and if I run refresh or rescan disk, I should be able to see that the D drive, the disk which is used for creating the D drive, has now been extended. Now what I'll do is I'll click on extend volume, click on next, 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 finish, and this should increase the D drive on our server. Similarly, now changing the D drive, E drive and the C drive is very much similar on this machine. But if you were using, but if you had the same sizes for the D drive and the E drive, that is the disk with the same size, then this is how you could use the PowerShell script to actually get the details. That's it for this video, folks. That's it for this video, folks. I hope you liked it and was informative. That's it for this video, guys. I hope this was informative and you liked it. Thank you so much for watching. Keep having a great day.